Hello and welcome to this video on NP theorem and a specific example of its application. Have you ever played a game where you are offered a choice and in making a decision, it is possible to cut off every other event that follows that one? If you have never played a game with such a mechanism, you would certainly have lived such a process or experience in your everyday life. It is the quintessential problem of do you take the left or right path at a fork in the road. NP theorem looks at this where the decision that can be solved is the problem, or more accurately, the problems, plural, and how each is a step of P in NP. And the NP is the way a decision at one point can create a different outcome to solve the possible list of solutions and see where the ends are. Dating sims, RPGs, and more all rely on such a setup of problems and solutions for gameplay reasons and storytelling. Let's start by stating that the examples used here are based on a very short timeline and on a relatively limited number of choices. The longer the time frame and the more complex the decisions that need to be made, the more difficult it is to apply NP theorem. With that, let's explore what NP theorem is. N and NP are the classic problems. N is defined as problem solvable in polynomial time. Polynomial time is the number of steps in a calculation. Think of this as cracking a lock that uses a finite number of options. As you cycle through each option, you are removing a possibility. Very crude, brute force password crackers will use exactly this method. No matter how long the lock code is, it does not change how the process works. NP is more like calculating the fastest route through a city. Which roads get to where you want to go, and will turning left, right, or going straight be the fastest route, and will it get where you want to go? The last step occurs again because you recalculate from each intersection as to whether or not you should turn or keep going straight. This is in part why very complicated and then thoroughly encrypted passwords are so hard to crack. If you have to not only guess until you have a model as to how the encryption has changed the password, you will take many years for simple passwords. For complex passwords, it is many lifetimes of work. These are highly complex but solvable problems using NP. This latter set of problems is very much like the branches of a tree. To get from the trunk to the end of a branch on the outside of the foliage, you need to choose the right steps. This is just like a decision tree. The process is what happens in a dating sim. Some paths lead to success while others lead to failure. When applying NP, you do not just look at the sim and work through a series of decisions once, then backtrack to the last fork and choose the other option. No. NP takes all the possible choices or branches and contemplates them at the same time. This of course is only possible on a theoretical machine called a non-deterministic machine, partially where we get the NP from. In reality, we use the first method, and this is done in what we call deterministic machine. This last point is where we need to go before getting to dating sims in practice. Because we can distill the problem down to something in the NP category, we may already have some way to solve it as part of an area called NP complete. That is problems that are similar enough to existing solutions that can be applied, albeit sometimes creatively. What is more is that there are problems in the NP complete category that have solutions under the P category. That is problems that we have a fast and effective solution for. Because we can translate the P solution to the NP complete problem, we can now solve things quickly that were previously only going to get harder the more steps that were involved. This is where computer science, mathematics, and programming cross over and intersect to create their bastard love child. When applying this to practice in dating sims, things are a practically perfect example of NP in application, more so if you are a completionist. Let's start at the beginning of the game. Here we have Doki Doki Literature Club. You have 4 choices or branches depending on who is best girl. Choosing one will exclude the other 3. Technically in Doki Doki Literature Club there are only 3 options initially, but you'll understand why there are finally 4 and at the very end only 1, if you play. This creates the first branch in the first iteration of problems for you. Who do you choose and how do you then satisfy them? As you can see, depending on who you want to choose with the very first decisions, you need to pick from a list of words. This is just like picking the numbers to a combination lock. The more matches with one of the girls, the more likely you are to experience a positive interaction. This is repeated 3 times for each playthrough, unless you want the good ending. To do so, you must save scum and reload after each poem is written and satisfy each girl's requirements. A similar process to what MP posits as the way to solve the decision tree, and this applies to a dating sim in this case. Go through one series of steps, get to the end, save, and then reload back at the start. By doing this, you can then follow the second and third and finally 4th pathway to that same point in time and identify where each branch goes. Of note, Doki Doki Literature Club is more akin to a visual novel than an actual dating sim, but it provides a fairly good example of what's going on when you try to apply MP theorem to it. You have to figure out which steps are going to lead to what consequences and why. By choosing this, we also avoid some of the more common issues around spoilers. If you want to know what is the best path to take to reach the end of one girl's arc, then MP theorem is how you do this. It lets you know which decisions provide the best results with the fewest possible steps. This is based on a theoretical approach that calculates what's going to happen from each event and then picks the one of the fewest steps to the very end. Of course, best girl is always Rem. Finally, we suggest not using Doki Doki Literature Club as a guide to dating. There are definitely better options out there. The same ideas we've described so far are used by programs trying to calculate how to get you from one side of a city to the other. Which roads based on traffic, the ability to turn, the distance, and the speed. All of these play into the guidance you're given on what is the best route to get from place A to place B. If you want to crack a password that has been encrypted, you need to figure out not only which pattern of events create that encryption, but then whether or not there is a way to match that encryption to a given password. It's something that is very important, especially in the modern world. It's also something that is incredibly hard to do. If there is a way to reconcile the MP portion of things with the P portion and get MP complete for all MP problems, there is $1 million prize. Admittedly, that $1 million prize also applies to proving that you can't do exactly that. Thank you for watching this video. If you found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions that you have below.